Understanding pollution. What is the environment? Before we can understand pollution, we need to define the environment. There are many meanings of the word environment. The one we will use for this course is the surroundings or conditions in which a person, animal, or plant lives or operates. We look at our surroundings. What is surrounding you right now? Air, water, and soil. Now we can ask, what conditions are those surroundings in? Are they clean or polluted? What is pollution? Pollution can be defined as anything that has a negative impact on the environment. Therefore, pollution is anything that is introduced into the environment that harms the environment into which it was introduced. What are the types of pollution? Organic chemicals such as pesticides, polychlorinated biphenyls known as PCBs, oil. Inorganic chemicals, salts, nitrate, metals and their salts. Acids, sulfuric, nitric, hydrochloric, etc. Physical, eroded soil, trash. Radiological, radon, radium, uranium, etc. Biological, microorganisms, pollen. What does pollution come from? Many would say that that is an easy question to answer. Humans. Do animals pollute? Say, for example, cows. Do plants? They take in carbon dioxide and produce oxygen. But remember, it is the impact on the surroundings. So in some cases, it may not be negative, but in others, it might. Man-made pollution. From the types of pollution just discussed, you could list organic chemicals, the pesticides that we produce, inorganic chemicals, the nitrates, etc. we produce, acids, we produce them to create products. Physical. We cause soil erosion by our activities and we generate trash. Natural pollution. From the types of pollution just discussed, you could list inorganic chemicals, for example, metals, salts, and nitrates found in the soil. Radiological, for example. Radon is a noble gas produced by the radioactive decay of radium found in uranium ores, phosphate rock, and a number of common minerals. Other sources of natural pollution. Volcanoes. They emit sulfur dioxide, chlorine, ash, rocks, etc. Physical. Natural erosion creates sand and dust. Biological. We have pollen and microorganisms. How are we reducing pollution? Developed countries are doing more than less developed countries. Enforcement of laws tend to be the key factor. Some less developed countries may have laws but do not do an adequate job of enforcing them. The U.S. has had environmental laws since before the 1970s. An example of U.S. laws passed. After the Bhopal disaster in India, discussed in the textbook, the U.S. Congress passed the Emergency Planning and Community Right to Know Act, EPCRA. It requires industry and communities to prepare emergency plans to minimize harm in case of an accidental chemical release. It also gave easy access to information on the hazardous chemicals used, stored, and transported through our communities. Pollution prevention. An example of pollution prevention is known as P2, or P squared. P squared is defined as developing steps to reduce pollutant emissions when a product is manufactured. For example, packaging detergent in a box too big for its contents, so we redesign the package to use less material. What is toxicity? All substances are toxic. The dose makes the poison is the rule. It depends on what dose is given, how quickly it is given, the health of the person who is exposed, the age, and the gender of the person or animal exposed. Examples of toxic substance are oxygen. You can die from too little or too much oxygen in your atmosphere. 19.5% to 23.5% oxygen in the atmosphere is required for us to survive. Water. If you drink too much water, you can die. This is called water intoxication. The symptoms are similar to alcohol intoxication. Again, it depends on the dose given. What is chemical risk assessment? Risk equals the hazard times the exposure. If you are exposed to a chemical, the hazard of that chemical, its toxicity, and how much you were exposed to is the risk to you. Why do chemical risk assessments? They provide answers to many questions. What is the risk of a chemical to a child? What is the risk to being exposed to a known carcinogen? Upon cleanup of a hazardous waste site, what levels are acceptable if the contaminant cannot be removed completely? Steps in risk assessment of a chemical. Dose response assessment. No observed adverse effect level. Highest dose a laboratory animal can tolerate without showing ill effects. They add a safety factor and determine the reference dose, which is divided by the no observed adverse effect level by the safety factor. We look at risk characterization. We take all the information and calculate the risk or hazard quotient. Hazard assessment. How is the substance hazardous? Example, is a respiratory hazard? Exposure assessment. What is the source? What is the route of exposure? Inhalation, ingestion, absorption, skin contact. Does the response assessment, dose response assessment, and risk characterization. I hope now you have the complexity of pollution but can understand exactly what pollution is.